All right, today we're going to be talking about in 8th grade, Chapter 1, Lesson 1. This is all about rational numbers. So when we talk about rational numbers, it's a set of numbers. And in fact, it's all of these numbers in here. So we're going to label this entire box as rational numbers. So a rational number is a number that can be written as a ratio, which is a fraction, in the form of A over B, where A and B are any number, but B is not equal to 0. Now, an irrational number is just the opposite. It's a number that can't be written as a fraction or a ratio. So if we go back up to our diagram here, the rational numbers, some examples of these would be fractions, mixed numbers, improper fractions, terminating decimals, and we'll talk about that a little bit, repeating decimals, we'll talk about those also. Now, this inside circle, the largest one, these are called integers. Integers, if you recall from last year in 7th grade, integers are numbers that don't have fractions or decimals. So these would be like -2, 1, 17, -48. Those are rational or integers. We're actually going to make these all negative because the only difference between integers and this next circle is the fact that integers can be negative. So this next circle would be the whole numbers. And that'd be positive numbers that aren't decimals or fractions. And then this innermost circle. These are called natural numbers. These also can be 1, 2, 17, 48. The only number that doesn't fit into here, that does fit into the whole numbers, is 0. 0 is a whole number. It's not a natural number. So let's start talking about decimals now. We have two different kinds. We have repeating decimals and terminating decimals. Repeating decimals are decimals that continue in a pattern. The way we show what part is repeating is we put a bar over the top of the numbers that are repeating. So for example, if I have 1.3 repeating, I put a bar over the 3 because the 3 is repeating. It's going on in a pattern, and this means it goes on forever. A terminating decimal is a decimal that ends. Or the formal definition is a decimal where the part that continues on in a pattern is 0. So for example, 1.5 is a terminating decimal. We can add a million zeros after this. It's not going to change the fact that this is 1.5. So that is the part that's repeating. So if I have a 0 as the repeating part at the end, that means it's a terminating decimal. We can just forget about that part. So, example 1, let's write 3/16 as a decimal. There's two ways that you can do it. One, you can do the long division. I just need to write it correctly. When we write long division, the numerator, or the top number, goes inside the house. The bottom number, or the denominator, goes outside the house. Now, 16 doesn't go into 3. So we put a 0 here. And we make this really look like 30. 16 can go into 30 one time. 1 times 16 is 16. And 30 minus 16 is 14. I'm not left with 0 here, so I have to bring down another one. Now 16 goes into 140. Eight times? 8 times 16 is 128. Subtract the 2, we get 12. Still not at 0 here, so I need to continue on the path. 16 goes into 127 times. 7 times 16 is going to get you 112. 112 taken away from 120 is 8. Still not at 0. So I'm going to bring down another 0 here. 16 goes into 80 5 times. 5 times 16 happens to be 80. Subtract to get 0. So 3/16 as a decimal is 0.1875. If you have a calculator, you can simply do the division on there. But in the event that you like the long division, you can use this. So on your calculator, if you have one of these, you would do 3 divided by 16. And that equals 0.1875, which happens to be what we got here. Example 2, write -3 and 2/11 as a decimal. Couple different ways that we can do this. First of all, we can kind of pretend like this -3 isn't there. And just put it off to the side. Because this -3, this represents 3 wholes made of 11 parts. So this isn't going to change. So really I'm looking for the decimal of 2 parts out of 11. So 11 goes on the outside, 2 goes on the inside. 11 doesn't go into 2, but it can go into 20 one time. 20 minus 11 is 9, not 0, so I need to bring down another one. 11 goes into 90 8 times, which would be 88. Subtract, I get 2. Notice how there's a 2 here and a 2 here. If I were to continue this pattern, it would move on indefinitely. Because this is a repeating decimal. So now what I do is the 18, the 1 and the 8, is the part of the pattern that's repeating. So this is this is the entire pattern here, and it's the part that's repeating. So I'm going to put down just one of those repetitions, the 1, 8, and I put a bar over the top to show that that repeats forever. Again, another way that you could do it is on your calculator. 2 divided by 11 is 0.18181818. Notice that there's a 2 here. what the calculator does on any repeating decimal or any decimal that extends past its screen, it rounds this last number. So this number should be a 1, but the number that would come after that is an 8, which would round this to 2. So do not get confused by that. On your calculator, it rounds at the end if the number of decimal points goes past the screen. Now, if we have decimals and we want to write them as fractions, what we have to do, there are two things. One is we have to find the last place value of that decimal. And whatever place value it's in, that last number, that place is the denominator. For example, if I have 0.1, the 1, the last place value that this decimal has, is the 10th place. So the denominator would be 10. And then the third part is put the decimal in the numerator. So the decimal is 0.1, so 1 goes in the denominator, or into the numerator, sorry. For example, if I had 0.16, the 6 is in the hundredths place, so the denominator would be 100. The numerator would then be 16. Now, this fraction is not in simplest form, so I'd have to get it there. There's a common factor of 4 between 16 and 100. So I'd have to simplify that fraction, but that is how this one would be done. So example 3, write 0.32 as a fraction in simplest form. The 2 is in the hundredths place, so this number here is in the hundredths place. So the denominator would be 100. The numerator would be 32. And again, there's a common factor of 4 between these two numbers. So I'd had 8 over 25. Now, what I could do to check that work is use my calculator. 8 divided by 25 gets me 0.32. And that's how I would check my work to see that I did it correctly. Last two examples, these are the tricky ones. There is a trick to this, but you need to figure out what that trick is. Now, so as we progress through this question here, write 0.7 repeating as a fraction in simplest form. What we do is we set this decimal equal to a variable. Next thing I want to do, there is one number being repeated, and that number is in the 10th place. So I'm going to multiply both sides by 10. So I now have 10n equals 7.7 repeating. Again, the reason why I multiplied by 10 is because the 10th place is the last part that's being repeated. Here now, I want to get rid of this repeating part. So I'm going to subtract it away. And I can do that because there's an infinite number of 7s here, an infinite number of 7s here, so all of them would evaluate to 0, and I'd just be left with 7. Now on this side here, I can't just take away 0.7, but 0.7 is equal to n. So I'm going to take away an n. So if I have 10 n's and I take away one of them, I'm left with 9 n's. Do not get confused. 10n minus n is not 10, because this is 10 times n. Now, I want n all by itself, So this is a one-step equation now, so I'm going to divide both sides by 9. So I'm left with n equals 7/9. And if I use my calculator, 7 divided by 9 should be 0.7 repeating. And it is. Again, remember, this last number gets rounded because the calculator rounds once numbers go past the screen. Last example, example 5. I'm going to set this number again equal to a variable. Now, the last place value that's being repeated is 100. So I'm going to multiply by 100. So I have 100n equals 545.45 repeating. Next thing I'm going to do is I want this repeating part gone. So I'm going to subtract the repeating part from it. So I'm left with just 540. Now on the other side, I have to be careful because I can't just take away the repeating part. I have to take away an n because 5.45 repeating is n. I took away 5.45 repeating over here, so I can take away n on this side. 100n minus 1n is 99n. I want n all by itself, so I divide by 99. So I'm left with n is equal to 540 over 99. This right here is an improper fraction. I can take 5 99s away from 540. And if I do that, I have 5. 5 times 99 is 495. So 495 taken away from 540 is left with 45. There is a common factor of 9 between these two. So I'm left with 5 and 5 11ths. And that is how you change repeating decimals to fractions. Now again, there is a shortcut, but you need to figure that one out on your own. If you have any questions, please let me know. Otherwise, this is the end.